Hello, this is Naz from NB Lessons. This is my first Calculus 1 lesson. I am going to teach you Calculus 1, Calculus 2, Calculus 3 from A to Z. I'm going to go ahead and post my lessons on teachable.com and some on TikTok. So, if you have any fears about calculus, go ahead and put them aside because I'm going to break calculus for you in baby steps so that you can understand it conceptually and apply that on your exams. And once you graduate and you become electrical engineer, mechanical engineer, civil engineer, or your major is math, you will know the fundamentals of calculus. That's the base thing. That's my aim, to teach you the fundamentals of calculus so that you can pick it up and conceptually understand what calculus is. So let's dive in. So what is a calculus? What is the derivative? That would be the first thing in calculus. What is a derivative? Derivative is nothing but rate of change. Okay? So for example, I have this pen in my hand, right? And if this pen is moving from right to left at the constant speed, is there a rate of change? There is no rate of change. The pen is moving at same speed, so the rate of change is zero. Okay, it's constant. There is no change. So that's, my friends, fundamental of derivative, rate of change. If this pen was accelerating, right, increasing speed every second, then the derivative would not be a constant. It would be something different. And we will get into that. I will teach you that also. So without any further ado, let's go ahead and see if we can dive in. So keep in mind, derivative is rate of change. Okay? And in some ways, this rate of change is also slope of line. If you recall from your algebra, slope of line is rise divided by run. So keep that in mind, and I will show you that also. So the punchline is that derivative, if somebody asks you, hey, what is a derivative? You can tell them with confidence, it's rate of change. Okay. So let's see if we can go ahead and draw some diagrams so you can understand it better. Let's say we have y-axis and we have x-axis. Okay. On x-axis, I have time, right? So I have said 1 second, 2 second, 3 second, 4 second, 5 second, and so on. 1, 2, 3, 4, 5, and so on. And on the y-axis, I have position. Okay. So this is my position on y-axis, and time on x-axis. So now, let's say in 1 second, you move 1 feet. In 2 seconds, you move 2 feet. In 3 seconds, you move 3 feet. Okay? So then, if I plot this graph right here, this graph is going to be a straight line like this. All right? So this is going to be straight line. Now let me ask you this. Do you see any rate of change in position? No, I don't see rate of change. It's constant because at 1 second, it's 1 feet, 2 second, 2 feet, 3 second, 3 feet. So there is no change. There is no change in the rate of change from perspective of position. Okay. So then we can say P with respect to time, function of time, is equal to a straight line. You agree with that? This is pretty straightforward. It is a straight line. There is no change. Okay, there is no rate of change. Like I explained you, if this pen is moving at constant speed, there is no rate of change. But if I increase its speed, yes, then it's a rate of change. An ugly example would be, I'll just go ahead and give it to you and I'll erase it. Let's say if you have a graph like this. This is your time, all right? this is your position, and you have graphed something like crazy, something like this. Now, in this case, your position, the rate of the position is changing, right? Position is changing with respect to time, but not in this case. Okay, so I'll go ahead and delete that. I guess I jumped ahead of myself a little bit, but I just kind of wanted to give you the flavor of this. Okay, so then we say position of time is a straight line. Now let me ask you this. Do you recall this from your algebra? Pt is equal to mt, where m is slope. Okay, and what is a slope? I just explained you. Slope is rise divided by run. You can confirm that right here also. You pick a point, okay,